take a look at your hands. Or maybe how about you rub your two hands together? Do you think your hands are smooth? Well, regardless of what you think, your hands up close are anything but smooth. For example, if you looked at your hands under a microscope or even with a magnifying glass, you will see peaks and valleys, folds and rifts. There are plenty of hiding places for a virus to stick. And if your hands were dirty, for example, there were a virus on it or something else, and then you touch your face, the virus can infect you. Thankfully, there are two really simple ways you can keep that from happening. Can you guess what they are? Well, perhaps these days you are using these things like crazy. They are soap and water and hand sanitizer. However, are they the same? And which one is better? Let's examine some of the differences between soap and water and hand sanitizer. The coronavirus that causes COVID-19 is one of many viruses whose protective outer surface is made of a lipid bilayer. A lipid is one of a group of chemical compounds that do not dissolve in water. Some examples of lipids include oils and fats. A bilayer means a layer that has two levels. Bi usually means two. For example, bicycle has two wheels. Biannual means twice a year, happening twice every year. Binary means two. For example, off and on, 1 or 0. Binary. So again, the coronavirus is one of many viruses whose protective outer surface is made of a lipid bilayer. These lipids are pin-shaped molecules, and their heads are attracted to water. However, their tails are repulsed, or we can say that their tails are scared of water, is another way just to help you to understand it, but of course it's not actually true. Therefore, in a water-rich environment, lipids naturally form a shell like this, with the heads outside and the tails inside. Hey, were you paying attention? Let's check and see. Quiz time, quiz time. Question number 1. What are lipids? Please select one of the following options. Option number 1. Circular molecules that fight coronaviruses. Option number 2. Dirt which hides virus particles. Option number 3. A water-rich environment. Option 4. Pin-shaped molecules whose heads are attracted to water and tails repulsed by it. What is the definition of a lipid? You may pause the video and continue when you think you have the answer. Okay, time's up. What are lipids? The answer is option number 4. Lipids are pin-shaped molecules whose heads are attracted to water and tails repulsed by it. Question number 2. What is the definition of the prefix bi? Number 1, two or twice. Number 2, one or once. Number 3, a protective outer surface. Number 4, a protective inner surface. What is the definition of the prefix by? Again, please pause the video and continue as soon as you think you have the answer. Right, time's up. The definition of the prefix by is option number 1. It means two or twice. So we talked about a lipid bilayer. That means there are 2 layers of lipids. A bicycle has 2 wheels. If a person is bilingual, that means they speak 2 languages. Okay, and now one last question for the time being. Question number 3. What is the definition of repulse or to be repulsed by? Option number 1, to stick to something. Option number 2, the opposite of to be scared of. Option number 3, the opposite of to be attracted to. And finally, option number 4, to pull towards. Time's up. What is the definition of repulse? The answer is option number 3. Repulse means the opposite of to be attracted to. We said that lipids are molecules whose tails are repulsed by water. That means the tails will try to avoid water if possible. In a water-rich environment, lipids naturally form a shell like this, with the heads outside and the tails inside. Their shared reaction to water makes the lipids stick loosely together, and this is called the hydrophobic effect. Ouch! Actually, this outer structure helps the molecular machinery of the virus break through our cells, especially our cellular membranes, and then hijack or take over our cells. Thankfully, it has thousands upon thousands of weak points where the right molecules could pry it apart and destroy them. And this is where soap comes into play. A single drop of any brand of soap contains a really, really large number, quadrillions of molecules called amphiphiles. And these amphiphiles resemble biological lipids. Their tails, which are similarly repulsed by water, compete for space with the lipids that make up the virus's shell. But they're just different enough to break up the structure of the virus's membrane, making the whole thing come crashing down. Those amphiphiles then form bubbles of their own around particles, and these include the virus's RNA and proteins. Therefore, if you then apply or use water, what will happen is that you will wash that whole bubble away, and now you have clean, virus-free hands. Okay, well, good job. Thank you very much. Thank you very much for listening to the video today. I hope you learned something. I hope it was useful. And take care. See you next time. Goodbye.